All right, this is the final video for 14.1. They really put a ton in there. And this time we're going to be estimating the square root of irrational numbers. Now remember, irrational numbers are numbers that don't terminate. When they're in decimal form, they don't have an ending. They go on forever, and they don't repeat. So non-terminating, they don't end, go on forever, and they never repeat. So it's not like a 0.33333. It just kind of like pi is an irrational number. It's 3.14159265, and nothing ever repeats in there. It doesn't follow a pattern in the end. It just goes on and on and on with no numbers repeating in the decimal places. And so the square root of 10 is one of those numbers. And so we're going to be estimating how to find the square root of that. And so let me, in order to do that, one of the first steps that you do is you're going to find a perfect square root, perfect square, that's just above it and just below the number that you're given. So for this case, it's a square root of 10. That's obviously not a perfect square. It's going to be an irrational number, but the one just below it that is perfect is the square root of 9. And the one just above it, there's nothing for 11, not 12 is not perfect, 13 is not perfect, 14 is not perfect, 15 is not perfect, but the square root of 16 is a perfect square. And so we know that it's in between these two numbers. Now it has to be just above and just below. It can't be like the square root of 4 or something like that. It has to be the square root above it and below it. That's perfect. And that's where that chart will really come in handy for you. But this equals 3, right? And this equals 4. And so if we're estimating the value of this, we know that it's got to be between 3 and 4. And so it's going to start with a 3. So it's going to be 3 point something. We don't know what that something is yet, but it can't be 4 point something because that was like higher than it. And so if it's between these two numbers, we know it has to start with a 3, right? As you can see, I'm still getting sick. Sorry about that, guys. So if I want to estimate this number, I'm noticing that in between here, there's no space. There's no numbers in between here. But between 10 and 16, you got 11, 12, 13, 14, 15, and you got 5 other numbers in here. And so I'm definitely thinking that this number has got to be close to 3 rather than closer to 4. So what you actually do is after you get the just above, just below, you kind of, now we're just estimating the number. So let's do 3.2. And since we're talking square numbers, it means you're going to multiply the two numbers together. So 3.2 times 3.2. And I'm just going to try that out. I don't know why I picked 3.2. I'm just thinking that these two are so close together. So let's try it. And I do 2 times 2 equals 4. 2 times 3 equals 6. And then placeholder, 3 times 2 equals 6. And 3 times 3 equals 9. I add these together. 4, 12. Oh, look at that. 10 and 24 hundredths. So that's too big, actually. So I know that 3.2 is too high. So I'm now going to go to 3.1, and I'm going to multiply that times itself because we know that a square root is two numbers times itself. And so I'm going to do 3.1, and I'm going to do, okay, this equals 31. 0, that becomes 3, that becomes 9, and this is 1, 6, 9, and it is 9.61. And so, looking at these two numbers, actually, this one is closer. Look, this is 24 hundredths away from it, and this one is like 39 hundredths away, like 39 hundredths away from 10, and this is 24 hundredths above it. So this is actually a closer estimate to it, but we know it's too big. So I think if I was just going to the tenths place, I would accept either one of these. However, I think we could get even closer. let's try another number. So we know it's between 3.1 and 3.2. And I'm thinking that it's closer. It's kind of almost like in between these two. And so let's do 3.1. Let's go 6. 3.16. 16. Now this is by hand. You don't have to necessarily go this far out. I definitely want you to the tens place. Maybe the hundredths place. You don't have to go any further than that. But let's get a close estimate here. But do you see how I came up with that? I was kind of looking at these two numbers and I was like, this is too high, but it's closer to it. And so I was like, it's definitely not spot in between it. So it's definitely, I think it's a little higher than 5. So let's try the 6. So this is 36. 9. Go here, it's 18. You're not going to have a calculator for this, so you're just going to have to muscle through it. 6, 1, 3. Don't forget 2 placeholders here because I'm multiplying by 3, so I need a placeholder for this and a placeholder for this. 3 times 6 equals 18. Carry the 1. 4, and then 9. So if I do this, 6, 5, 18, that would be 8, 9, right? Yeah, 9 and 9. And so I need 4 place values. 1, 2, 3, 4. Wow, look at that. 998 and 56 hundredths. So that is as close as you could possibly get to 10, probably without going over. Obviously, we could take 3.161 or something like that. But I think we're so close to it. I think that 3.167 would be too much since we're so close. We're within 2 hundredths. Even if we round this, it's like 9.99. So we're like within 1/100th essentially of it. And so if I estimated this out, it would be 3.16. And you use these little squiggly lines to show that it means about. Okay. Let me show you one more. Whew. Okay. So if I'm going to estimate the square root of a number, let's do the square root of, let's do 18. Okay. So your first job is to think of a perfect square. That's one lower and one higher than this. So if I'm thinking one lower, 16 was there. That was a perfect square, right? And so I got 17 in here, and then I've got 18. 19, no. 20, no. 21, no. 22, no. 23, no. 24, no. Square root of 25 is a perfect square. Does that make sense to you? Okay. And so I know that this is 4. The square root of that is 4. And the square root of 25 is 5. So I know it's got to be 4 point something because it's between 4 and 5. And so it's going to be 4 point whatever it happens to be. Looking at this, I'm noticing that there's a lot of space in here again. And so I'm thinking that it's really much closer to 4. And it's not even like halfway there. So I'm thinking more again like 4.1, 4.2, somewhere in there. So let me try 4.2. Do you see how I'm coming up with those numbers just to guess? I'm kind of looking at this in a linear way. I'm trying to look at like how close is this to this. And it's not a perfect way of doing it, but it kind of gives me my decimal place number that I want to use. And so I'm going to do 4.2 times 4.2. The reason why I'm doubling this is because the square root means what number times what number is going to give me 18. And so that's what I'm trying to figure out. I'm trying to figure out these two numbers that are multiplied together. And of course, it's a decimal number, but I can only estimate it because it's not a perfect square like other numbers are. So in this case, 2 times 2 equals 4, 8, 8, and then 16. And so add these together, 16, 7. So I end up with 17 and 64 hundredths. So let me try 4.3. I'm betting that's too much, but I'm still going to try it anyway. 4.3. That's going to give me 9, 12, and then 12 here, 16, 17, 9, 4, 8, 1. And so, yeah, it went over it. And so I know it's between 4.2 and 4.3. This one is about, or it's 36 hundredths away from my real answer. So if I added 36 hundredths to here, I'd end up with 18, right? And this one is like 50 or 49 hundredths away, right? So this is 49 hundredths too much. Sorry, it's hard for you to see. This is 49 hundredths too much, and this is 36 hundredths too less. And so let me see what I would get if I would go in between these two numbers. And so this one was closer. So let me try 4.24. Let me try that. And let's see if I can get even closer to it. Okay, so I know that this is closer. So if I was going to estimate it, I would say 4.2 if I wanted to go to the tenths place. But if I want to go one step closer and see how much closer I can get, let me see if I can do that. So 4.24 or 4 and 24 hundredths, 16, 8, 9, 16, 8, 4, 8. Two placeholders. Don't forget those two placeholders. And then I've got 16, 8, 9, and 16. So end up 6. That's 10, 16, 17. That's 10. That's 19. That's 17. That's or 7 and 1. And so I need 4 place values. 1, 2, 3, 4. And look at that. 17.97 or 17.98 if I would round it. And again, I'm 2 hundredths of the way. 2 hundredths of the way from it. So if I was going to estimate this, I just had a lucky guess here, then I would estimate this to be about 4 and 24 hundredths away. So the square root of 18 is about 4 and 24 hundredths. So your first step is to determine perfect squares above and below the given number, right? Okay. Your second step is to see which, you got to kind of guess numbers now. You've got to kind of like plug some numbers in. Think first, is it going to be halfway there? Is it going to be above half or below half? And then you narrowed it down to 5 numbers after that. And so so that gives you, this gives you the whole number, right? That gives you the whole number. And then you can kind of estimate the tenths place by determining if it's above or below one or the other. Okay, if it's above 5 or below 5, and that's kind of like looking at how close they are to one another. I knew that it wasn't halfway between 16 and 25. It was closer to 16, so that's why I started with 4.2, and I just guessed that number. I just decided to start there, and I was like, too low, let me try 4.3. That's too high, so I know it has to be 4.2 something, and that's how I got that. Go ahead and practice with a partner on this. Go ahead and use your square root keys to help you, and that should put you in the right spot. And you good luck on it, but work together to help each other out.